there's been one question about PECs and how PECs can reduce the need for backup power, like batteries or even the size of PVs. Has there been any research on that yet, or is that to come in the new Annex?
Yeah, it's a very good question, but I think with the current knowledge that we have, and I think it's hard to give a generic number for it because it would depend on quite a lot of factors. So even though we don't have the answer yet, I didn't mention today, but we have a new annex that is Annex 87, which is focusing, excuse me, on personalized environmental control systems, and these type of issues and their benefits and quantifying these type of benefits is part of the work that we plan to do. So I don't have an answer to this yet, and also in its own it's hard to provide a generic answer, but hopefully we'll have something within a year or two. That was for the first one.
Okay, that's thanks. And yeah, maybe you can just continue with the second one.
Yes, perfect. I'll do that. So the second one said, "Great work, thanks." Well, thank you. So one thing, I think it's a very good point as well that that's mentioned. These solutions, I mean, tabs itself is of course for new buildings, but there's an alternative for that, which is basically incorporating something called phase change materials into radiant ceiling panels. And the point of those type of products or the cooling solution is that basically it can provide the same benefits of tabs, but you can use it in renovation of buildings, but also you can use it in lightweight buildings. And the working principle is similar to tabs, that basically you have the radiant ceiling panel, but you have phase change material incorporated into the ceiling panel. So you basically have a thermal mass that is sitting basically in the ceiling, and because of the pipes and the water circulation, you can actively control. And we have works on it and several studies on it showing that it actually does work like tabs. And I don't see who asked the question, but if this person is still interested, you could reach out to me and I'll be happy to discuss this. And the same thing related to PECs is that it can also be used in renovation of buildings, and we do not necessarily see it as a new building solution. And in the further continuation of that question, there's something about the costs. We did a study where we compared costs of tabs, all air systems, and these radiant ceilings panels with PCM with phase change materials integrated. So there's a study on that, and what we saw was that originally tabs was the cheapest, then it was all air was the second most expensive one, and the PCM panels were the most expensive. But then in the same study, what we also saw was that with the higher cooling loads, the PCM started to become more beneficial because it had higher energy savings compared to the all-air system. Similar to work on it related to the PECs is also part of the new Annex, Annex 87. But I think in general, the questions about costs and how to include them in decision making, of course, it's very critical. It's very important, but I think it's a very tricky topic. So we will work more on that as a part of the new Annex. And there seems to be nothing else for me. Thank you for the great questions.
Okay, thank you, Ongun. Matt is not here anymore. We have one question, but I think there are two questions for Gamze. If you could answer. So there was one. I think it's related to the temperature level of the coolant. So how far can you cool down with your adsorption chiller?
So it depends on the first question. It depends on the system. But we achieved to reduce the temperature of the system delta T, I mean the temperature change, to 10 degrees Celsius. So if it is coming as for example, 15 degrees Celsius, we achieved it to reduce it around 3 and 4 degrees Celsius. But it depends on the system. So it depends on how the temperature is coming as an inlet temperature of the chilled water. So, but we achieved to reduce it to more than 10 degrees, but most of the absorption chiller is around the 5 degrees Celsius. For example, if you have 12 degree inlet, it's getting out around 7 degree, but we achieved to reduce it to 3 and 4. So the other one is the, could you please share the system efficiency? Okay, so as I said, it depends on the system. Again, it depends on the temperature of the system. How much do you have? How much wastage do you have? How much the temperature of the inlet temperature of the chilled water, and also the ambient temperature. But we achieved to see the general COPs of these systems is around 0.5 at 6, but we achieved to 0.85, which is the highest value in the market right now. So so it depends on the system, but in IDD, as an inventor of the system, we are just making out, for example, a tailor-made system design for your systems. So we are just dealing with the, we are not producing only just the one absorption chiller that will be in the market. It will be variable and it will be tailor-made and it will fit to your system. Firstly, we are analyzing your system and we are getting data from your system, and we are doing some research on it, and we are adapting it to your system. That's the key point for the IDD. So that's why the reducing the temp, we want you to take more efficiency from that system. So the third question is, I think Sotek has involved into a Parhenite. Yes, I know it is a cool line, so this could be on the market as well. Yes, it could be, but I guess they're on the way to the market. And also, as I said, we are embedded the condenser to the inside of the absorber. So this is the innovative part of the GD. So I guess they're the commonly designed absorption chiller. I have not seen it, but on the market yet. But we just reduced the size and the weight of the absorption chiller. It was so important, because when you're transporting this huge chiller system, because it could be 60 kilowatt cooling capacity, it could be 250 kilowatt cooling capacity. So the size could be increased to 3 and 5 meters long, something like that. So the transportation will be cheaper with the design of this one, for the third question. And the fourth question, I'm curious to learn what has been learned.
Should I read it out loud?
We are on the market right now, but because of the issues, yes. So
the main obstacles for your new absorption chillers, maybe.
I didn't get the point right here.
You mentioned several other systems that had problems and are not on the market anymore, and I would understand the question is, what are the main difficulties?
The main difficulty here is because we just developed an absorption chiller, which is so specific, but right here the application is so important. So that's why you need to adapt it, as I said, to take the highest performance to their system. So, for example, you're going to a plant. They have, for example, 80 degrees Celsius waste heat, water from the waste heat. So we are just designing a heat exchanger to them to take, for example, the chimneys outlet waste heat. We are converting it to hot water, and also we are just generating some, we are also doing some tailor-made issues, and we are designing the absorption chiller again, and then we are putting it over there. So the whole procedure is a very hard issue. So we're doing the whole procedure. Even the products in the market, most of them is applicable by the companies that they're doing some HVAC applications. So they do not know anything about the absorption chiller. So they are just taking it and adapting it to your system, and they're looking at the temperatures of the which is written inside of the brochure. That's all. But we are having a tailor-made absorption chiller for the companies. So this is the difference for our system. I guess I got the question right.
That's perfect. Thank you so much. We have another question for Ongun. I don't know if we still have time. Maybe we can answer that via email. Or still have got time, Ongun?
Yeah, I mean, I think I'll try to answer, and then people can if they like. But I actually have a counter question. What does global mean? I mean, I just don't get the question.
Yeah, I mean, so.
But maybe then the person can reach out to me, because I would like to know what is meant by that. So
perfect.
Please reach out to me. Sorry, I couldn't get the question.